Table 8 provides results of the baseline equivalence analysis. The results are provided for each outcome variable and for each specified baseline covariate. The table shows the treatment group mean, the control group mean, the difference between the means, the difference in effect size or standard deviation units, the standard error of the difference, and the p-value to assess whether the differences are statistically significant, that is, different from zero. By default, RCTS uses a 5% significance level, but that value can be changed using program options. As you can see in our example, none of the differences are statistically significant, suggesting that the treatment and control groups are balanced. In addition, RCTS conducts a joint test of significance across all the baseline variables considered together, which are not significant in our example. Tables 9 and 10 present the impact findings. Table 9 shows impacts on study outcomes for the full sample and for baseline subgroups. The structure of this table is similar to Table 8 for the baseline equivalence analysis. So what do we find for our example? We see that the treatment group mean for the math test score is 58.39 compared to 56.04 for the control group. Therefore, the impact estimate is 2.35 scale points, which translates into an impact in effect size units of 0.18 standard deviations. The standard error is 0.88, and the p-value is 0.019. Therefore, the impact is statistically significant at the 5% level, which is denoted by the star above the p-value. The caret next to the star indicates that the impact remains statistically significant after applying a correction for multiple hypothesis testing across the two test score outcomes that can lead to spurious positive impact findings. Now let's look at this 0.008 p-value in the row with the SG Math Prof subgroup. This p-value shows that the difference in impacts between the math proficiency subgroups is statistically significant. We see that the impact appears to be larger for those with lower levels of math proficiency at baseline than those with higher levels. There is no evidence, however, of differences in impacts on math scores between girls and boys. In addition, there is no evidence that the after-school intervention improved reading test scores for the full sample or for any of the considered subgroups. The notes to Table 9 provide information on the calculations. They also provide information on regression R-squared values and clustering effects. These are important parameters to help design future evaluations. Table 10 provides information on how much the impact estimates vary across blocks. The table shows a standard deviation of the block impact estimates, the range, the proportion that are positive, and the p-value to test whether the block impacts differ from each other. For our example, we see that there is some variation in the impact findings across school districts, suggesting that the intervention was more successful in some sites than others. Thus, it might make sense to conduct additional analyses to help understand this variation.